Thank you. So, it's my pleasure to welcome you to the session Climate Research in Extreme Environments, a model for civil-military integration. This session is co-organized by the Department of Earth System Science and Environmental Technology of the National Research Council. And so, please let me to introduce our our distinguished speakers. So, Dr. Paolo is a chief of the Global Atmospheric Watch Program of the World Meteorological Organization. Then we have the General, Giuseppe Addesa, is the head of the General Office of the Military Aviation and Meteorological Office of the Italian Air Force. Then we have the Dr. Stefania Gilardoni, is a senior researcher of the Institute of Polar Science of the National Research Council. Then the Dr. Jacopo Gabrieli, researcher of the Institute of Polar Science of the National Research Council. And last but not least, the Colonnello Alessandro Nossen, who is Vice Commander of the Alpine Training Center, Italian Army. So, the rapid changes observed in polar and high mountain regions, including shifting atmospheric composition, global atmospheric transport, and paleoclimatic dynamics are critical indicators of planetary health and fundamental for projecting future climate risk and informing international policy. The session proposed a tangible and successful model for overcoming these barriers and strategic collaboration between civil research and military support. This partnership leverages the unique capabilities of National Defense Organization to create stable, secure platform for discovery. The Arctic and the mountain regions are warming at a rate faster than the global average. The implication of this rapid change extends beyond this area, affecting mid-latitudes and other parts of the world. To predict and prevent the severe consequences of this change, we need to enhance our understanding of the cause behind this warming and environmental transformation. This knowledge cannot be obtained by a single entity, but we need cooperation and to reach new projects and to reach new solutions for the change. So now we will hear Dr. Paolo about the international initiative focusing on the Arctic and glacial environment. Please, Paolo.
Thank you, Francesco. Thank you for the invitation again. This is my second session in a row, so I hope you don't get bored with what I'm saying. I already discussed a bit the role of WMO. But before starting, I would like to acknowledge also Generale Addesa, who is the representative of Italy with my organization, the World Meteorological Organization. So if I can, what I will be discussing today is the need of international collaboration. As you mentioned, this is key everywhere, but this is really key for the challenges in the Arctic. And I would like to also mention the role of the Met services in this collaboration, international collaboration. If you can go to the next slide, I'll start with the tipping point. I guess most of you are aware of the tipping point. Basically, it's the point of no return. This is for the cryosphere. This is from the global tipping point report of last year. And you see the tipping point in the link to the cryosphere. I'm not going into the details of these tipping points, just to say that there are plenty. This means really risks, vulnerabilities for the environment, for population. This is basically, this tipping point are part of the Arctic amplification system. We know that changes are occurring extremely fast. And we know that the current models, they sometimes are failing to model how fast these changes are occurring. And this is again a message that I said to another session yesterday. Research is fundamental. We need research. We need to continue research in this area because without research we cannot predict things with at the right level of uncertainty. The scientific community is also working on this teleconnection framework. The fact that we know that what is happening in the Arctic will have consequences also outside of the Arctic. The changes in the Arctic are affecting the global weather, instability. Some regional patterns are really directly connected to what's going on in the Arctic area. And so this is, again, a matter of elevating risk to the population. It is important for people that are living in the Northern Hemisphere, but I would say everywhere, to know what are the changes that are taking place in the Arctic. There are positive feedback loops that we don't understand, negative feedback loops that we do not understand, and we need to understand that better. And this is why the scientific community, I don't know how to, yeah. This is why the scientific community is organizing this the 5th International Polar Year, which will be 2032-2033, but what you see in the graph below is the fact that we are now almost entering the ramping up for the different activities that will be coordinated part of IPY number 5. So the idea of IPY is really to coordinate research, observations, monitoring in the polar regions. And we've seen from different sessions with this conference that there are many activities that are organized at country level, at regional level, and it is true that we need to make sure that we have a certain level of coordination. It's very good to have the scientific freedom to do what we consider best. We know that, to take the words of Julia Schmaler, we know some of the unknowns, but there is also some unknowns that we don't know. And so it is important to give to keep the scientific freedom, but with a certain level of coordination. And this is IPY5. We need that. We know that the changes are occurring in the Arctic are not only about physical science; they are also affecting population, and we need to include social scientists in the framework. And I think this is also a need. There is a need for coordinated action, working with indigenous population, working with the indigenous knowledge. This is really fundamental. The fundamental issue that we are dealing with IPY is that no single nation can achieve alone, and you said that already. I think this is really what is the essence. We have to work together. Beyond IPY, we also have other initiatives, and I will mention one of the initiatives that we organize at the WMO with the World Climate Research Program, which is a co-sponsored program. Some of you may be actually experts in the program, and we have the UN Decades for Action on Cryospheric Science that started last year. I think this is also a place where we identify where the new products and services should be developed to anticipate and plan for consequences of changes in the cryosphere system, including the Arctic. And this is where national meteorological and hydrological services can play a role. I think it is really in the essence of the Met services to do the monitoring, to share information. This was the basics of the WMO. And so this is extremely important that together with the IPY, we continue with this UN Decade of Action for the Cryospheric Sciences with enhanced observations, again, monitoring, data sharing, and modeling. And this is why we have the WMO in IPY as a UN agency that is really engaged in making sure that we have a coordinated action with all the parties to the WMO. We have at WMO the WMO Integrated Observing System, which collects all the information, which informs all the countries about what is available for making sure that we have the modeling capacity. So we are working on data standardization, we are working on data management, data sharing, we are informing members, we are producing integrated assessments that are directly used for the different UN resolution and UN conferences. We will support with WMO the satellite monitoring of the cryosphere, we'll support the development of initiative approaches, and we will foster exchanges of and collaboration and partnership. WMO is 193 members from all over the world, and with all the countries facing the Arctic, members of the organization. With that, I will stop, and I thank you very much again.
Thank you very much, Paolo. Thank you. I just want to leave key messages from your presentation. So the research is fundamental for understand the complexity of the system. We need international cooperation to reach the knowledge of the Earth system inside that no single nation can achieve alone. So we have opportunities from APY 5 and also from the UN Decade Action on cryosphere. And I want to say that Italy participates in international organizations such as WMO through delegates from the Italy Air Force, and the Air Force have strong leadership on national research, national meteorological services that remained at the forefront of the international meteorology for over a century. So I leave the floor to the Generale Giuseppe Addesa to give information on your activity.
So welcome everybody, thank you for the invitation. I'll quickly answer probably a question why a military in uniform is representing Italy at the WMO. Normally all the representatives at WMO are the offices of Met Office all over the world, 192 nations. But the answer is in this slide. So we had our first model for meteorological prediction in Italy in 1910, well before the Air Force was built in 1923. And we have 115 years, so from 1911 we have all the meteorological data in Italy on paper, and right now is going digital. For what reason? Because it's the fuel for AI, so for artificial intelligence and machine learning to understand why the climate is changing so fast. So that was the past, of course, but the past is also linked to the future. So that's why I'm the representative not only at WMO, but I'm also the representative of the defense, so of the Ministry of Defense at EUMETSAT, ACMWF, EUMETNET. These are organizations, pan-European, most of them, that deals in different ways of what is the outcome and the output for weather, especially if we see in the last 10 to 20 years severe weathers. Just for information, for example, ACMWF has 3 sites, one in Erding, in UK, one in Bonn and one in Bologna. In Bologna, we have our supercomputer. That is one of the fastest in the world. But this supercomputer is not only used for ACMWF. Right now, in the US, they use model from ACMWF for their weather consideration. This was impossible to think when I flew first time in US in 1990s. So that's something that as a European, it's something that we do, and we do for all over the world. That's why at WMO we want to help especially countries that they don't have the capabilities to study severe weather impacts, and that's why over there you have also the second portion, early warning for all, meaning that we have to take as a nations our capability also not only to preserve ourselves, but also to help all the nations that are not capable of this. And with that, you see also on the slide the SAF. That's also something we use, especially for the hydrology. This is all done via satellites with the EUMETSAT. And on the bottom, you can see the picture of the increasing temperature, especially in the poles that we have seen during these few days from yesterday and today. That's one of the effects. But what we still don't know what is the effect is going to be on the normal climate at our latitude, so where most of inhabitants on the Earth live, not only in the poles, on the high mountains. How do we do this? We do this especially with our history, but also with recent programs. You can see over there we have our weather station in Monte Cimone, and over there what we do is we are one of the 33 stations all over the world. What we do over there, we analyze the CO2 in an environment that is above, of course, where the human being is affecting, like you cannot do a CO2 implemented here in Rome, so you have to do it at altitude. And what you can see below on the graph, you can see from 1980 to 2020, not only the increase in percentage, but you can see the increase in scale. So from 1.2 part per million per year, in the latest years, we are increasing 3.5. So it's a curve that is increasing daily. And the effect, of course, is what we see right now, but we still have to study, because there are macroscopic effects on all the climate for the Earth, but also microscopic effect. What we can see, for example, in Rome, the hydraulic system of Rome was built 2,000 years ago and was never changed. So there is the river Tiber in the center. The amount of water that can sustain this is flexible on the diameter of our system. And this system was built for typical rain that today we had in the last few years, not only in Italy, but in Europe, in the world. Capability of rain that in 2 hours, 3 hours, you have the amount of rain that normally you should have in 3 to 6 months. So that's something that we have to study and to cure for, of course, helping all the systems. Another part that I want to highlight is space weather. We are working with the National Institute of Geophysics and Volcanology and Astrophysics. For what? If I say space weather, probably most of you, unless you are a specialist, you say, I don't have a space weather app on my mobile phone, so it doesn't help me. Actually, it helps you a lot. When we drive with our car, our GPS, if there is a space weather impact, will not work. Our credit card to pay, it will not work. So this is something that normally at the military system we use a lot, because there are impacts on space weather, but we are doing this also for the civilian, because there are impacts also on our society. Imagine a system, for example, automatic bus system that is working on GPS and programs, and these electromagnetic fields can impact this. So there are a lot to do on this, and this is something that we are, I would say, at the beginning, but it's something that also for the future, because we know that a lot of information that we have today, talking about supercomputer, the future supercomputer is going to be in the orbit. It's not going to be not even here on the ground, if we think about Starlink and SpaceX to give internet all over the world. And finally, I will conclude with what we do in extreme region. I heard here the third pole, so the North Pole, South Pole, and extreme in the high mountains. So we have 4 years of collaboration with the National Antarctic Research Program in the Antarctica, where Italy has, of course, one base. And over there, what we can do as a defense system is to project a dual system of logistics to provide what normally a civilian system is not capable of. Over there, we can see a C-130 that can land, of course, on a sea-based ice runway, but it can land also at 50 degrees on a dry desert, so it's open to everything. And it is something that we have to be, because we have to study right now, because it will affect our life more and more daily. Thank you.
Thank you very much, General. We have heard about the active engagement between Aeronautica Militare and research bodies such as CNR, but the others in our nation, but also in other places such as Antarctica. So now I will introduce Stefania Gilardoni of the National Research Council, who will introduce and show the research activities of the Testa Grigia Observatory. Here, CNR and Aeronautica already work together for studies and future projects. Please.
Thank you, Francesco. And thank you, everybody, for being here. Good morning. Testa Grigia is also a meteorological station of the Aeronautica Militare. And like the Arctic, also high elevation mountains are climate hotspots. We have heard several times today and also yesterday that the Arctic is warming almost 4 times faster than the global average. And the European Alps, during the last 2 decades, are warming 2 to 3 times faster than the rest of the world. We have tested this also analyzing the temperature trend in the Western European Alps during the last 2 decades. And again, we observed that the warming trend is about 0.5, 0.6 Celsius per decade, while the global average is 0.2, 0.3. So in this context, high elevation platforms are perfect platforms to monitor the drivers of climate change, but also to understand and predict how the climate change is going to impact the environment. So today I'm going to talk to you about the Testa Grigia Observatory. The observatory is in the Western Italian Alps at 3,480 meters altitude and is part of the high elevation observatory network of the National Research Council. The Testa Grigia Observatory, we monitor atmospheric long-range transport. We also monitor atmospheric composition changes, and we study the interaction between the atmosphere and the cryosphere. The observatory was inaugurated in 1948 for cosmic ray measurements. And only recently, in 2021, we started aerosol research. We analyze aerosol microphysical properties using machine learning approach to be able to identify the different aerosol population regimes that characterize the observatory, so essentially to understand what kind of transport we have towards the observatory. And we see that for most of the time, especially in winter and during nighttime, the observatory is reached by clean air masses. About 1/3 of the time, we are able to see the transport of very tiny, fine submicron particles to the observatory, which are coming from the lower altitudes, so from the boundary layer, the surrounding valleys, but also from long-range transport. And occasionally, about 6% of the times, we also see the transport of cores, so bigger and light-absorbing particles that are coming from the Sahara region. And these are called Saharan dust events. The Saharan dust events, as also other approaches that are presented in previous studies, were identified based on the aerosol microphysical properties and based on the analysis of the air mass origin. In this case, we use Lagrange-Tobeck trajectory. And we observed that in general, there is a good agreement between the Saharan dust events identification based on observation and what is forecast by the CAMS ensemble model. And there is also quite a good agreement between the model and observed mass of the dust, so PM10 concentration. Another important point, we actually observed that these dust particles are usually characterized by a higher ability to absorb light than pure mineral dust. And this is due to the fact that these particles coming from the desert are actually mixing up with black carbon along the transport, which gives them a higher ability to absorb visible light. And this is important because dust in the mountain region, after depositing on snow, it can accelerate snow melting. We see that the frequency of the dust events was highest in spring, summer, so let's say from March to June, and also in October and November. But we observed that the amount of dust that is transported during the spring and summer events is much higher compared to the dust that is transported in fall. And this is important because in spring, we can trigger the snow melting process. So to understand the reason for these differences, we analyzed the synoptic scale circulation pattern for the Saharan dust events during the different seasons. And we see that the events in spring and summer are characterized by this high pressure system over the eastern Mediterranean and Libya, which leads to strong winds coming from the central part of the Sahara Desert. So winds that are able to transport dust towards Western Europe and Central Europe. On the contrary, during the fall dust events, this high pressure system extends towards the west, and so it makes it possible the transport of dust only from the northern part of Africa, from Morocco and Algeria, which is known to be a less effective source of dust for the atmosphere. So anyway, the observatory is a wonderful place not to monitor only dust events, but also long-range transport of wildfire plumes. August 2024, if you were here for the session of Black Carbon this morning, was a season particularly intense for the activity of fire in northwestern Canada. And the observatory, we observed that between the 21st and the 23rd of August, the absorption efficiency of the aerosol increased, the black carbon concentration increased, and the fine particle concentration increased, up to value almost 3 times higher than the summer averages. And so we look at the origin of these air masses, and they were coming across the northern Atlantic from Canada. The plot on the bottom shows the black carbon mixing ratio, so essentially how much black carbon you have associated to these air masses. And we see that the red lines, maybe it's not very clear here, looks more like brown. Brown lines indicate that this black carbon that we observe at the Testa Grigia is actually coming from the Arctic, Canadian Arctic fires. So we don't only see how the emissions from the mid-latitudes can impact Arctic, but also what's happening now in the Arctic is impacting the atmosphere in Europe. And with that, I would like to thank you, and I would like to invite you to follow the website of the observatory. It's just a bright new website, and if you want to know more about our research, just get there. Thank you.
Thank you very much, Stefania, for your work in the station. So, the melting ice, both from Arctic and from our mountains, serve as a clear and dramatic evidence of how climate change is impacting our planet at a global scale. But also, ice acts as a record, revealing the climate history of our planet over hundreds of thousands of years. So the loss of this ice is erasing also this memory. Now we will hear from Jacopo Gabrieli about his research and field activities to prevent this important history. Please, Gabriele.
Thank you, Francesco. With these slides, I would like to give you a very brief overview about this project, which is iconic for our institute. So I'm trying to answer to 3 simple questions: what we are doing on the glaciers, how, and why. So let's start from here. We are in Ottedalfonna Glacier, Svalbard Island, close to 8 degrees north, less than 1,000 kilometers from the North Pole. And a couple of years ago, we spent 3 weeks over there trying to collect 2 deep ice cores. So drilling a glacier could be a very boring activity, because if it's all working properly, you have to repeat dozens and dozens of times the same procedure. But of course, in this environment, in this case, nothing was working properly. We had a very tough condition, cold, minus 20, 25 degrees, storm every day, and also many troubles with the drilling machine. And after a few days of fighting, we started to get the first results, so we were quite happy, but we had a surprise.
Okay. Down. Down. Up.
Tutto sul destro. So from the borehole at a depth of about 30 meters, we start to get fresh water with not only ice section but also fresh water. From does it come from? This water is the sign of the melting of all the glacier around Ottedalfonna. It means that, okay, in that days the temperature was minus 20, but during summertime we have a very massive melting. And this water is percolating through the layers and is accumulating close to the bedrock. So I say that when Catherine is the name of our colleagues, our Canadian colleagues, is putting her hands into the bucket of water, of cold water, she is really touching what the climate change is. So in this picture we see a serac in the Monte Rosa Massif. So we see that the glacier is composed by many layers. Each layer is overlapping the previous one, and each layer is a kind of, it's a page of a beautiful manuscript, very ancient and very precious manuscript. And this manuscript is able to tell us the history of climate condition, environmental condition of our planets. Some pages of this beautiful book are easy to read. In this case, it's a saran dust event, so a deposition of saran dust on a glacier. But many other parts are more difficult, because the history of the planet is written in chemical, physical, biological language. So we have to understand, we have to study that. It's a kind of cipher communication, and we need to have a cipher machine. And in our lab, we have the cipher machine. Cipher machine is our instrumentation that we use to try to understand the history of this book. A couple of examples. Here we are in the Colle del Lis, Monte Rosa Massif, and for example, analyzing the samples from this site, we understood that, that humans are able to impact the environment, even at these high altitudes. In this graph, we have the benzoypyrene, which is a polycyclic aromatic hydrocarbon. It's very important because it's toxic, and it's produced by all the combustion. The origin of that is from the first industrial revolution, when our grandfathers learned that burning fossil fuels, they can produce energy. And the energy is beautiful, because with the energy you can do whatever you want. But this is the other side of it. Because burning fossil fuels, you also produce a lot of pollutants, and you spread around all these pollutants. And we can find these pollutants also at the highest altitudes of the Alps. For another example, we moved to Antarctica. Here we are in Concordia Station. And here we were able to collect probably the most important ice cores of the history, the so-called EPICA project, the European project of ice coring in Antarctica. And from these samples, we were able to reconstruct the temperature changes over the last 800,000 years. And we also understood the strong correlation between temperature and CO2 concentration in the atmosphere. And we saw that during the last 8 climatic cycles, concentration of CO2 never exceed 300 ppm, and now we are more than 430 ppm. So no humans before us breathed such high concentration of CO2. So when a glacier is melting, we are losing a lot of stuff. So we are losing the landscape, we lose water, the water supply, but we also lose our memory, because in the glacier is stored the past of what we are. And if we lose our memory, we become blind. And if we are blind, we are not able to predict, to have a look on the future. So, of course, what we should do is to preserve the glacier. But preserve the glacier is very difficult, because we have to change our mind. We don't have shortcuts. We have to decrease, to stop, to emit greenhouse gases into the atmosphere. So it's difficult, but what we can do now is to preserve the memory of the glaciers, and this is the project. So in every site, this is an international program in which Italy is involved, of course. From each site, we drill 2 parallel ice cores. The first one is used, is analyzed in our labs to understand what we are able now. And the second core is stored in Antarctica, close to the Concordia station. And it's a kind of gift for the future generation. When the glacier will be disappear, and this is the fate of many of our glaciers, the samples will be stored in Antarctica. And I'm finishing. Ice Memory is also a beautiful project, because it's a very good tool to speak about climate change to the normal people, I would say, to the community. Because if I speak about climate change using the physical laws, if I speak about climate change using radiative forcing, this kind of stuff, it's boring. Nobody is listening to me. But if I speak about climate change showing the beauty of our glacier, of course, it's much, much easier. Thank you.
Thank you, Jacopo, for your activity to preserve the memory of glaciers. And I want to also introduce the last speaker. So we need military personnel and researchers that are capable of operating in this environment. So I leave the floor to Colonnello Nossen, who will illustrate the Mountain Training School of Italy. Please.
Good morning. So today I try to tell you a story of cooperation, mutual trust, that start from the need to understand an environment and to move and operate in an environment. So we start from to try the similarities between Arctic and mountain environment. So we start from our needs, the operational, the military needs that start in mountain, in high mountain, with all the limitation of the high mountain. Someone is really similar to the limitation that we have to front potentially in an Arctic environment. So we speak about persistent low temperature and so on. So the step after is to understand our capabilities, because the center, the military training school as personnel very specialized in mountain environment. And from many years we collaborate also with ENEA with the Antarctic expedition. So we have a personal capabilities, a personal experience. But what is the step after is to have a better comprehension of the Arctic environment. So we need to understand that comprehension. We have to enter deep in the question, start to collaborating with university and institute of research. This kind of collaboration permit us also to understand which are the lacks in terms of technologies and materials. So we start to collaborate also with and industries to develop some product, some stuff, item that consent us to move freely in the mountain, high mountain, and the Arctic environment. In the end of these conceptual steps, we also arrive to develop doctrine, so change how we think now to move and to operate in a mountain, passing through the Arctic environment. So in this strict collaboration with the universities, we organize a camp in the glacier near Courmayeur, Mont Blanc, with many universities that trust in this project. So the school, the training center, provide a safe and secure environment in a particular environment, so at 4,000 meters, and start the project. The project involves also the argument of physiology, because we have to understand how the soldier react in extreme condition. And one of these is the hypoxia and low temperature condition, because the soldier have to maintain also a sort of alertness also in this kind of condition. And the cognitive neuroscience help us to understand how work the decrease of the cognitive neuroscience. In the end, the human performance also help us to understand the recovery and how to manage this kind of situations. In the end, we can say that the training mountain center became a national Arctic hub and continue to extend collaborative networks. So we like to enlarge our collaboration with universities and institutes because we continue to enlarge and expand our training modules. So with the collaboration, we understand something new we can do in the glacier, and we are ready to improve the relationship to enlarge this kind of module. In the end, we try to keep in touch also with enterprises to develop new product to consent us to be prepared to operate in the Arctic. Thank you.
Thank you very much, Colonnello. So, since we don't have a lot of time, I just want to ask a very short question, and you have 30 seconds each. Is enough? So, the question is, Paolo, please, you can take the microphone. What is the potential step in your mind to improve the collaboration between the civil agency and the military bodies?
This is a difficult question from the point of view of the World Meteorological Organization. It is true that, as mentioned by Il Generale, Italy is a very specific together with there are other countries where meteorology is run in the country with the militaries. I think what we can say is that the organization, the meteorological organization, rely on services, and this is often a service. It means that you have to provide something in the long term, that you need to be ready, well organized to give this service provision to everyone. And sometimes the universities, the research centers are not the organization that can do that. And it is true that in some countries, the organizations that are connected with the militaries are the best organizations to do the work. Not everywhere, but in some countries it is the case. So I don't know if I answered your question.
Yeah,
but this
so
is
we
how
have to improve our connection. That's the answer. Thank you. So, General Addesa, please.
In few words, information sharing. So I believe that information sharing today, where information is power, and we can see also in cognitive neuroscience, information sharing these fields is paramount to make sure that where somebody have a lesson identified, somebody else maybe with other tools can transform this lesson identified in a lesson learned and come back maybe with a better solution for the both of us or for multiple organizations. So information sharing for me is paramount.
Thank you. Thank you. We have to improve
Okay,
our data.
I go very quickly.
Please,
I take these words and I say that I really like the idea of information sharing because we need those, especially at Testa Grigia, for understanding the aerosol processes. But my answer is another one. As I point you out during the presentation, we are really interested in the long-range transport because long-range transport and how it changes over time, even driven by climate change, is changing the way we can impact the Arctic, and the Arctic is going to impact us. So to be able to understand the link between climate change, transport contaminants, and meteorology, we need to have a strong collaboration with what can give us this data, as Paolo said, so with the Air Force. Thank you.
Jacopo.
Working on glaciers and especially at tight altitudes or Arctic is very demanding. So what we would like to improve is the presence of military personnel just to help us. It's just something that we have, but to improve in terms of logistics and safety.
Grazie, Jacopo.
Yes, we are starting in a month the planning for the new campaign on the glacier for the end of 2026. So I think we can use also this occasion to make network and to strengthen contact also, because we are ready to cooperate with anyone who want to pursue the same goal. Thank you.
Okay, this is the Spantic Glacier, that one, this project. Okay. So I think we have similar consideration, that connection, data, and training. So these are the key words. But we have 5 minutes, then I want to leave the floor to question and answer from the public. Please raise your hands. Don't be shy. Yeah, yes.
Thank you. Larissa Lorenzi from the European Commission. I would be interested if you could highlight the areas where dual research could be interesting in the polar regions. Thank you.
Could you please repeat? Probably they don't understand. Say again, sorry.
It wasn't clear? So the dual-use research, which parts would be applicable from your perspective in the polar regions?
Something I can tell about. Yes, many kind of resource of studies could affect also normal life. We come recently from a symposium in which we speak about design, for example, design in Arctic, design in how to realize, for example, a tent or a bag. This kind of research make with sense, obviously, can reflect in civil product with success in many time.
Other question? One? If you want to add something, okay, please, thank you.
Thank you for the presentation. My name is Federico Dallo from the CNR. My question is for the Aeronautica Militare about the data sharing. I think this is very important, and do you see any potential conflict when you collect data, for instance, in the polar areas, data that might have some military value? When you talk about like sharing this kind of data, do you mean like raw data, or you think about some kind of embargo or some situation in which you need to deal with this kind of maybe possible conflict? Thank you.
So is a dual answer. Of course, in every aspect of civil-military cooperation, there is always an analysis before of what kind of information sharing can be released, but it is not because the military wants to keep the information, it is for the safety of the population, and we can see this for the geopolitical situation today. So of course, when we analyze the data, we have a double analysis, and most of the data is released to the public, and to the public I mean to the academia, to the research centers. Now, talking about raw data and not raw data, this is a little bit different because there is, of course, investments. And according to me, like there are associations like ECMWF, EUMETSAT, EUMETNET, where, of course, nations, they have to pay some bargain at the beginning of the year to make the machine working. So according to me, if you want to have the raw data, of course, you have to be part of the family, paying at least the due, or this we do also with some nations that maybe they have some problems financially, then you can also do a provision in kind. So with researchers, for example, or personnel. That's what we were discussing before when we talk about civil military. Normally, in the civilian, the logistics is a civilian logistics. The military logistics, of course, is done for military use. So according to me, the data is always open unless there are some data that are classified for any other reason. But this normally is not the military who decide. It's a government level, either national or multinational, thinking that we are part of organization like European nation, so EU, but also NATO. So these I don't know if I answered this question, but normally the data are freely used.
Perhaps I can add a view from the UN organization that is promoting data sharing since many years. First of all, I think it's working. I mean, we can produce weather forecasting because there is exchange, and the countries are exchanging the information at the right level. I don't think it's not only a matter of military versus non-military organizations. I think the issue perhaps is the fact that we need more environmental data, and some of the environmental data can be connected to issues that are a bit more problematic to share, river discharges and things like that. So I think the idea is that we need to agree on essential variables that we can share. Perhaps not all the raw data can be shared, and we have to understand that. And we have to understand that it's also a learning process for different countries to go into more fairness. It's not that the data is fair or not fair. There is a degree of fairness, and we have to accept that, and we have to engage the countries with more data sharing, not asking everything from the start, and think that as a process.
Thank you very much, Paolo. Thank you very much to all the speakers. We finished our time, and I hope you had great hour here. We discussed about best practice and future collaboration between the civil and military agency. Thank you very much again. Have a good lunch.